Hello, ladies and gentlemen. Today we are looking at function operations. There are four of the regular operations, the ones that you've known since grade school: addition, subtraction, multiplication, and division. And then there's one extra operation called composition. Function operations can be extremely detailed. We're going to look at it numerically so that it's a little bit easier and that we can get through it quickly, and then you'll see it again in pre-calc. You can write this two ways. You can write f of 4 plus g of 4. They are equivalent expressions, okay? I have a tendency to write it the first way, but you'll see it written the second way many times. So f of 4 plus g of 4 should say to you to find f of 4, find g of 4, and add them together. F of 4, I'm going to plug in. Notice, please, that there are 5 functions, each named differently, sitting right here. So that's where you're looking when you want to do your math. F of 4, negative 2 times 4 plus 2 equals negative 6. G of 4, that would be 16 minus 4 equals 12. And then we add them together. Negative 6 plus 12, and we get 6. So that's all we're doing here. We have 4 operations before we move on to the new operation. And so then let's move on to subtraction. So subtraction is just as simple as addition. The trouble with subtraction, the same thing we always have trouble with subtraction, is when we kind of forget to follow through with the signs. So f of 4, remember this is the same thing as f of 4 minus h of 4. Notice that the order does matter. We already know that f of 4 equals negative 6. I also need to know what h of 4 equals. And for h of 4, I'm going to plug it into the h function, and I get negative 2. So when I want to subtract, I take my f first. F of 4 is negative 6, minus h of 4 is negative 2. And so I have negative 6 plus 2, which is negative 4. So that is subtraction. Of course, we can also multiply, and be aware, of course, that we're just doing this in a very basic way. Normally, we will be inputting functions, but today we're just inputting numbers, okay? Multiplication, again, this is the same thing as saying f of 4 times h of 4. So I need f of 4 first, and f of 4 we discovered was negative 6. H of 4 we discovered is negative 2. And when I multiply those together, I get f of h times, sorry, I keep writing f of h. F of 4 times h of 4 is the same as negative 6 times negative 2, and I get 12. Last, we have division. So think about what's happening here, okay? In addition, let's go all the way back up to the addition problems. In addition, I'm being asked to add together one linear and one quadratic. So if I add together, it's asking me to add negative 2x plus 2 plus x squared minus 4. And so if I add them together, I'm going to still have a quadratic because there's no other power in here. It's just straight up addition. Okay, so this is what f plus g equals. And if I plug 4 in here, I get 16 minus 8 minus 2 equals 6, which is exactly what I got when I plugged in the number. So normally, when you move on in this particular topic, you do the actual math with variables, but we're just plugging in numbers, so we don't really need to do that, but I just want to show you what's going on. Same thing for subtraction. This subtraction problem is talking about two linear functions, and therefore if I subtract them, I will still have a linear function. F times h on the next one, when I multiply together those two functions, so let's just look down here, f was negative 2x plus 2, and h, of course, is x minus 6. Notice you will get a quadratic out of this, okay? Your leading term will be negative 2x squared. I'm just going to put a dot, dot, dot here. So we're doing something, okay? We're doing something with these, but for our intents at this point, we're just plugging numbers in. But there is something happening behind the scenes. And the reason I'm saying that is because the last thing that's happening is we're actually creating a fraction. So let's just look at that, negative 2x plus 2 over h, which is x minus 6. I just created a fraction, and these are called a rational function. Rational function is simply a quotient. I've got one function on top of another function. And so if I plugged 4 into that, I would get negative 2 times 4 plus 2 over 4 minus 6, which is negative 6 over 4 minus 6 is negative 2, which equals 3. Okay, so that answer is 3, but I can certainly find it by plugging in. And that's what I'll do also. F of 4, we already know that f of 4 is negative 6. H of 4, we already know that h of 4 is negative 2. Negative 6 over negative 2 equals 3. Okay, next one. Again, we're creating a rational function, f over k, but we're just going to do this by plugging in. F of negative 1 is negative 2 times negative 1 plus 2, which is 4. K of negative 1 is 2 times negative 1 plus 1 squared. Well, that's a 0. Negative 1 plus 1 is 0, and it doesn't matter what power or what coefficient, I still have a 0. So when I write it up, I have 4 over 0. We have a word for that in math. Okay, the definition of division is that you are taking parts of something that is divided into a certain number of pieces. You cannot divide something into 0 pieces right here, okay? That can't happen. We call this undefined. There is no way that I can divide something into 0 pieces and then you can have 4 of them. Okay, a fraction means something is divided into 8, you take 3. So, those are the 4 operations that we know. The operation that you don't know is called composition. And function composition is the result of taking the output. So let's just write this here. Take the output of the first function, and by first, I do not mean the outside, okay? We'll see that in a minute. So your y value becomes your new x value. Input into the next function, okay? Composition. Functions are generally composed. For example, if you buy an article of clothing at a percentage off and then you have to pay sales tax on it, that is a composition of functions. The first thing you do is take the money off, 10% off, and then you use that answer and take 7% of it. So function composition is a completely normal operation in the world. All function operations. We don't generally just have one thing. We generally have many actions. For example, putting air in a tire. It's, one of the functions has to do with the size of your car, and the other function has to do with the weight of your tires. And of course, your car, tells you what to do with that in that instance, but it's following two functions. I want to look at function composition graphically before we do anything. So the first one says f of g of 2. You start at the inside. So the inside function, let's just make a note of that. So you find the output, and then move that output to become the new input. And that sounds super, super confusing, but it really isn't. So let's just be clear here, that is f, this is g. F of g of 2. The first thing I need to do is find g of 2. And it looks like g of 2 is 5. So g of 2 equals 5. I used that first because it's the inside function. Now I take that 5 and I put it into the f function, and I find that f of 5 is 4. So f of g of 2 equals 4. I can also say it like this, f of g of 2, and that's not a dot, it's an open circle. It doesn't say fog. It says f of g of 2. F of g of 2. All right, let's do the next one. G of f of 0. So that's number 28 on this sheet. So I could also write it g of f of 0. So I put 0 into the f function. F of 0 is 0. I take that output of 0 and put it into the g function. G of 0 is 3. Therefore, g of f of 0 equals 3. Okay, maybe take a minute and see if you can figure out the next one. Pause it a sec and then I'll do it. Okay, and again, I just want to make clear which function is which here. This is g, this is f. G of f of 4. First thing I want to do is find f of 4. So f of 4 is right there. It's 2, and then I move on and find g of 2. And g of 2 equals 5. So g of f of 4, and again I can write it both ways, equals 5. Same thing here, except it's not an image. It's an actual function. G of 4 is where I start. G of 4 is 4 squared minus 4, which is 12. And now I put that 12 into the f function. F of 12 is negative 2 times 12 plus 2 is negative 22. You're always starting on the inside, moving to the outside. Okay, and again, most of these are written as with function notation with the little circles, but every single one of them could also be written like this: g of j of 2. So j of 2 is where I start. J of 2 is 1. And then I take the 1 and move it into the g function, and g of 1 equals negative 3. Here's the g function. 1 squared is 1 minus 4 is negative 3. I can do this over and over and over again with as many functions as I need to. We'll just do one more, okay? Just one more before we call it a day. So again, you have a homework that is associated with this, and you have the front of the homework. And then on Thursday or whenever you want, you're going to listen to the other video, and then you'll do the back of the homework, okay? So here I start with -1. H of -1 equals -1 minus 6 is -7. K of -7, I'm moving from the inside to the outside. The K function says 2 times -7 plus 1 squared, which would be 2 times 36, which is 72. I move that into the G function. G of 72, still on 20, and sometimes you're really going to have to pick up your calculator here. 72 squared minus 4, and let's just see what that is. And that would be 5180. There we go. So that is function composition. This is your notes. Finish them, and then I will be collecting your homework. Have a great day.